Hello, my name is Dheeraj Bislawath.
And I'm Arjun Patel, and we're going to be presenting our final solution notebook. So the problem statement is to analyze the environmental impact of AI technologies, specifically in the financial industry, and we're going to have several claims to justify this. First, we're going to start out with assumptions that are key to making our model predictive, and I really want to focus on this last one, which is that the financial industry will maintain its proportion of machine learning and AI market share at 18%. We know that financial companies are very eager to adopt AI tools, but it's important to keep in mind that all industries are also similarly eager to do so. So even as the financial industry increases its use of AI, it will continue to be proportional, as so do other industries.
In order to support our analysis, we have provided a few critical claims. One of these include the most effective way to analyze these resource impact of the financial industry using AI is to analyze the yearly emissions and the water consumption of the total AI market, as those provide the best indications of how AI emissions from the financial industry will progress into the future. As well as we have provided three other critical claims that demonstrate why our mathematical models as well as our approach are best to forecast the AI emissions by the financial industry in the future. We first do this by analyzing emissions. By developing a custom mathematical model with a variety of different key variables such as users as well as the queries per user, we are able to best map the emissions year to year of the financial industry's involvement in the AI industry. We first do this by computing the given data sets model training emissions, and then we're able to forecast this and see how um, it will progress into the future, which we see that it's a constant growth into leading into the future. In addition to this, we have to find variables u, q, en, and em, which provide critical aspects to understanding the AI emission output by the financial industry over time. And we do this by either inferencing based on certain excerpts that we have found and providing weights to specific attributes that correlate most to the specific variables, such as the average queries um, made to AI technologies per year. And by culminating all of this, we're able to forecast into the future, and we are able to show that both logistically and through the use of the ARIMA model, that the growth of AI emissions will be substantial in the coming years. However, the ARIMA model shows that it may level off. These two forecasts, however, closely align, showing that our model is both has good performance as well as demonstrates our approach is correct and most accurate for the prompt.
We can also consider water. Emissions and water are the two driving key factors of impact of AI. So we also develop a custom equation that considers a variety of factors, and we focus on hypercenters. Hypercenters are where the majority of AI workload is done, and they require a lot of water to cool their computing systems. We use a bottom-up approach considering each hypercenter individually, and we group them by year built, as we found an interesting correlation between the year they were built and the water they consume. We forecast out the number of hyperscale data centers into the future, and we find that there is a substantial increase of the number of hyperscale data centers in the world. Then we look at the water consumption per hypercenter, and then we group them by year in order to make this analysis simpler. Looking at the trends of Google data centers, we see that there is a decrease in the amount of water consumption by year built, and this reflects that newer buildings and newer data centers have adopted emerging technologies with increased water efficiency. And it seems that there's an exponential decrease in water consumption due to the rapid development of these two new technologies. We can reasonably assume that this exponential decrease will continue as there is significant research interest in this area. We also correct for other factors, including considering what AI workload is not done at hypercenters. Forecasting all of this in our custom model gives us that the water consumption of AI in the financial industry actually decreases and cuts below half by 2028.
And overall, we come to multiple conclusions regarding the carbon dioxide emissions by AI. by the financial industry, mainly that it will grow rapidly and is on a trajectory to grow significantly over the coming years. Although more infrastructure will be built in order to meet these AI demands. In both the emissions and water consumption analysis, we see that resource consumption and emissions by AI will be substantial by the financial industry, and we need to make an effort to mitigate this extreme resource consumption.
In good research practice, we've included strengths, weaknesses, and how we conducted the technical computing. We'd like to move on to the policy suggestions. So I'm going to hand it back to Dheeraj to talk about emissions.
So our analysis shows that the significant majority of the emissions comes from training the models, not just operating them. And on the usage side, our data shows that not all AI tasks are weighted equally in terms of energy consumption as well as emissions. And the challenge is to basically minimize things like a number of queries as well as make more meaningful queries, for example.
In addition, financial companies should opt to put their AI workloads on newer AI hyperscale systems and those that reduce the amount of water consumption. There might be barriers to this that such options don't exist. However, we predict that they will in the future, especially if governments put tax incentives to create these options and there's grants put into research. If you have any further questions, please look at our sources and don't hesitate to reach out to us. Thank you for your time.
Thank you.